What we're doing is tying simple interest and compound interest to what you have learned in first semester, which is sequences. Alright? How we're going to look at one of the sequences linking to simple interest, one of the sequences linking to compound interest. Then, the third bit of the sequences, we look at three, arithmetic, geometric, and the first order. Then we'll use the first order sequence to link it to compound interest, thinking about if you borrow money, including what's the repayment and what's the period and that sort of stuff. Alright, so that's what we're doing, and it's actually a lot of real life application. Today, we're just quickly going to go through some review of simple and compound interest. Recall how to apply the formulas of simple and compound interest. Then we're going to use recurrent relations to model simple and compound interest. And recall how to use the sequence function of class back. Now, this time, you got to make it really clear. Initial amount has to be 0. Alright? That will make life so much easier, because like after one period, you're tying in the 1 with that period, or 2 with the period 2, 3 with the period 3. Alright? So think about it. Finance, generally, I would suggest start off with AO or whatever. 0, and then go to 1, 2, 3, and 4. So it will look something like this. So you've got an initial amount, let's say A0. Then after, say 1 year, or whatever period, that will be A1. After 2 years, will be A2. Alright, but be flexible. Read the question carefully and think how you want to define your initial amount. Alright, generally finance, I would say with A0. Alright, now, so if you recall, can you recall the recurrence interval? Can you determine the first 5, no calculator, 5 terms, and the 15 terms with calculator of the following recurrence relation? Try that now, please. Remember, in the exam, you must always use the term. For example, this is defined as U, this is defined as T, this is defined as A. Alright? Those are the marks that you don't really want to lose. You just want to make sure that you get your convention correct. So first 5 terms, generally no calculator. And of course, I start this one with 1 rather than 0, because it's just basically a skill things that you're doing. Of course, you know that one of them is geometric, one of them is arithmetic, the other one is first order. And anything with recurrence relation, you must state the first term. And also remember, in the exam, if the question asks you to derive a rule, it's always a general rule. It's never the recurrence interval, unless it specifically asks you to do that. Alright, let's quick check your answer. So this is how I did it. UN minus 5. So U1 is 4. What have I done with the first question? Yeah, that's correct. No. Number 1 is totally wrong. It should be 4, minus 1, minus 6, minus 11, minus 21. Alright? Alright, that should be 4. My fault. Have a sleep when I did that. And then I'm pretty sure U15 is incorrect then. Alright, but 2 is basically starting with 0.25 multiplied by 2, multiplied by 2, and multiplied by 2. And then this one starting off with 2. It's times 2 plus 3. Alright, and that you have to use your calculator. The answer for the first one is not correct. Alright, absolutely not right. I don't even know how I made that mistake, but anyway, that's life. All right, so what you need to think about is we have, with those three examples, I'm going to bring you back to the arithmetic, the geometric, and the first order linear recurrence. All right, A is always the first term of the sequence. What happened with arithmetic is a linear growth. You always have a difference. All right, the common difference. Yeah, whereas the geometric sequence is you have the common ratio. First order recurrence is practically the combination of both. All right, there's always a ratio plus the constant. Right? Yeah. Recall all this? Yes? Very good. So now, with arithmetic and geometric, you can write the recurrence rule or the explicit rule or the general rule. Whereas first order linear recurrence, we don't have any explicit rule. Right? Okay, let's move on. Now, simple interest or flat rate interest. Recall that. You have done this since year 9. So we know that I equals to PRT and interest is calculated as a percentage of the principal. The interest is not added to the principal of the subsequent year. All right? So it's always based on the principal only. It's not principal plus interest. And then you can rearrange and recalculate the principal, the rate, and the time. And then, of course, the final value is A, which is P plus I. All right? So important thing for you to recall is I equals PRT, I is interest, P is the principal, R is the rate, T is the time or duration. If it is less than a year, if the interest rate is given to you in percentage per annum, if it is, let's say, 6 months, you've got to divide it by 6. All right? 6 months is divided by 2. If it is 2 months, it's divided by 6, and so on and so forth. Remember, you need to be able to reduce it if the interest, if the duration is less than a year. Or if it is more than a year, you've got to multiply it by 1 point something. All right? It says 16 months is multiplied by 1.5. All right, everyone happy with that? Recall that. Now, let's try with example 1. Sasha invests $4,000 in an account, earning 5% per annum simple interest. How much interest will she earns in 3.5 years? What amount will the investment grow to in 3.5 years? So the first one, we use I equals to PRT, right? Or actually, let me show you how I would answer a question like this. Important. This is the principal, and this is the rate, right? So we are asked to find the T is 3.5 years, and we need to know I. And this is what we need to know, A. All right? So therefore, using I equals PRT, P is 4,000, R is 0.056 or 5.6%, and T is now 3.5 years, 3.5 years. So that should be $784. Pretty straightforward, something like this, just recall. And therefore, A is principal plus interest, which is 4,000 plus 784, which is 4,784. All right? Now, think about example 2. Can you give it a go a couple of minutes before I actually show you? This time, it pays interest every fortnight. All right? It's taking it to the next level. You're thinking about now every fortnight. How many fortnights are there in a year? 26. So what would the rate be changed to? What would the rate be changed to? Divide by 26 because you've got 26 fortnight. And what amount? So we don't know, this is interest per fortnight. So we know R is 7.2% over 26. Because per annum, we are changing it to per fortnight. So I equals to $15. So 15 equals to Principal we don't know, and 7.2% over 26. Now, we're talking about per fortnight. So the T here is now 1, because each fortnight is 1 T. Alright, you can solve for P. And if I'm not mistaken, P is 5416.67. Alright, note. It's always, you need to remember, anything to do with finance, if it is in decimal, note 2dp. Alright, this is the change in interest rate because you are changing the period. Alright, that's important. Now, if it is in calc, assume section, I'm pretty sure this will be in calc assume section, you solve in class 10. It's sort of like a warm-up question for you. In example 2 could be a warm-up question for the exam, and then it will start doing something different. Alright, I want you to try example 3, please, by yourself. See this question, the way it's written, the start of 2018, alright, and the end of 2018, and the end of 2025, alright? So think about the start and the end. This is the principal, and this is the rate. Now, that's part A for you. Part B, what I'm going to suggest to you is to make life a little bit more straightforward for yourself. You've got your fingers. You can always count 18, 19, 20, 21, 22, 23, 24, 35, 8 years. Alright? Use your fingers. I'm honestly going to tell you that works. Whatever works, it's probably the most straightforward way of doing it, rather than 25 minus 18 and then plus 1, all that sort of stuff. Alright? You're not counting up to 100, you're counting up maximum probably 15, 16, 17. Here. Advantage. Alright? So, you now know, use N is or T, PRT. T is now 8. T equals to 8 years. Therefore, I equals to 3,000. Or actually, I don't even have to do that. I can just use 8 times 150 because 150 is every year. Correct? Yep. Yeah. Thank you. So therefore, I equals to 8 times 150. Hang on. 8 plus 4 is 1200. Oops. What am I doing? It should be 1200. 1200. Therefore, A equals to 4200. Now, what I'm going to do is to use the same example. Alright. What if I use arithmetic sequence? Can you get a calculator out? What I want you to think about is, this time, $3,000 is, let's call it A0. Alright? I did use A there, that's good. A0. And then, the interest. This will be the difference. Yeah? So you know the common difference is 150, and you can rewrite it as a recurrence relation. A n plus 1 equals to a n plus 150, a naught equals to 3000. Can you use your class pad to calculate A8, not T8, A8? Please use your class pad to calculate A8. Get used to using your class pad again. Once you start using this, the next thing I'm going to teach all of you is the financial function. The financial function is not as intuitive, but I will teach you how to use the financial function. Alright, learn how to use your class pad. Recall how to use your class pad. Try with both recursive and explicit. So you know you have to change the type to A naught. Alright, you need to change the type to A naught. Get used to using your class pad again. So therefore I say for finance, generally I really like to use A naught or T naught or whatever. So it starts off the start. Start is A naught. End of 2018 is A1. Makes life, once you know that difference, it makes life a lot easier for you in the exam. Alright, everyone happy with it? Recall how to use your class pad? Yeah? Let's go on to the next one. Let's try this sort of question. How could you do it? Let's think about the question. Juan borrowed 4,800 for his parents. Alright, you know the principal is 4,800. And the simple interest rate is 5.6%. He is to repay the loan monthly over 2 years, which is 2. Determine the monthly repayment Juan will have to pay his parents and the final value of the loan. Alright, first we need to find out the final value. Alright, for here you've got words that vocabulary list and certain things that you need to know. Alright, your vocabulary list. It could be the other word for final value is future value as well. Alright, make a note of that. Future value is the same as final value. Alright, present value of course is always the same, the principal or present value. And future value is the final value. Alright, the slight difference is the future value could be the future value in 8 years rather than the final value. The whole investment is 10 years. Alright, but in this case the future value is the same as the final value. So we know that I equals to PRT. So we know P is 4,800, R is 0.056, and T is 2. So therefore, that is 537.60. Alright, so the future value or future final amount will be 4800 plus 537.60, which is 5337.60. Now, how do you work out the monthly repayment? The monthly repayment is actually 5337.60 divided by 24, which is 222.40. Alright? Now, question like this is what you have learned in year 9 or year 11. I'm going to twist the question slightly. Let's have a look at example 4 using sequences. All right? This is twisting the question slightly, which is a likely exam question. Think about the question. Read the question now. Juan borrowed $4,800 from his parents to help him buy a car. He repays his parents 222.40 monthly, and altogether he pays his parents how much? Determine the duration. So how are you going to determine the duration? Which one is A naught now? Which one is? How do you do? When do you actually go up to $0? All right. So the difference in this question and the previous question is pretty straightforward, asking you to find the monthly repayment. This one, you're given the monthly repayment, you're given the final value, and you know that the initial value is 4800. All right. You don't even need this value. This is now irrelevant. The important thing is find out the duration. How do you use sequence? So what I can do is rewrite this as, we know that this is the monthly repayment, that would be the difference. Correct? You're paying it back. You know the final value is this. This is the final value or future value. All right? So you know now, I'm going to start thinking about this. Take away that every month. Take away that every month until it comes to 0. So therefore, the way I would write it is, if I use Tn plus 1 equals to Tn minus 222.40. All right, T naught now equals to 5337.60. All right, can you try using your class pad and see whether it works? Use your class pad. So you can see if you use your class pad, let me write down. Alright, go to your sequences. This time, I'm going to make sure that you clear everything first. Alright, go to type. It's type A naught. So AN plus 1 is AN minus 222.40, and that would be 5337.6. Tap on that and execute. Sorry, just keep going, and you can see that at the end of 34 it's 0. Pretty straightforward. Yeah? Agree? Happy with that? Alright, let's go back to look at the lesson slide. So using ClassPad, we know that T24 equals to 0, therefore the duration is the 24th month. See, if you use T0, you don't have to think about adding 1 or taking away 1. Straight away is, you know, it's 24 months. Yeah, okay, good. Now, compound interest. This will be the one that you'll be looking at quite a lot, compound interest. The most important thing now, you need to know this bit. R divided by N and NT, where the N is the number of compounding periods in a year. All right, it could be 6 monthly, if it is compounded 6 monthly, the compounding period is 2. Correct? Because it's every 6 months. If it is compounded quarterly, quarterly is every 4 months, so that's 4 quarters in a year. Sorry, every 3 months, 4 quarters in a year. So it's divided by 4. All right? So think about it. If I have compounded half yearly, N equals to 2. Quarterly, n equals to 4. Monthly, n equals to 12. Daily, n equals to 365. All right, and so on and so forth. So you must be able to do it. Think about what n is. I think I've seen variation of 2 monthly after all. 2 monthly is n is 6, correct? Okay, so you need to be able to use this. Let's try example 5, $2,500 invested for 4 years with an annual compound interest rate of 6%. Find the value of investment at the end of 4 years if the compounding occurs annually, quarterly, and daily. Try that, please. Use this formula. A equals to P times 1 plus R over N to the power of NT. So, quarterly, annually N equals to 1. Quarterly N equals to 4, and daily N equals to 365. So therefore, I'll do the daily example. Equals to 25000 times 1 plus, the interest rate is 0.06 divided by 365 over 4 times 365. All right. And I can't remember what my answer is. I'll get my calculator. Get used to using your class back. And that will be A equals to 25000, 1 plus 0.06 divided by 4 times 4 times 4, to the power of 4 times 4. If I'm not mistaken, this should be 31561.92. And that is all right. Those are the answer. So you should be able to use that, because what we're going to do eventually is apply this compound interest formula and use it as a sequence. All right. Now, if I write it as 25000 to the power of 1.06 to the power of 4, does it look familiar? Do you think that looks familiar like a general rule of geometric sequence? Yeah, that's familiar. That is actually a general rule. That is your common ratio, correct? All right, let's try. All right, let's try this question, please. The next one we will work on. I will use this example for geometric sequence. Let's think about this without the geometric sequence first. So we know R is annual compound interest rate compounded every 6 months. All right, so N equals to 2. How many years will it take an initial investment, P, to grow to 3700? So we know the final value is 3700. And this is 2500, 1 plus 0.08 divided by 2 to the power of 2t. All right, we don't know what to the power of 2t. Alright, that's important for you to know. Then we can use solve in the class pad. And 2t equals to 9.95792, and t therefore equals to 4.997. So it's after 5 years. Alright, now let's use the same question and look at how you would use your sequence. This time we know that this is T0 and we don't know what this is. However, we know the interest rate. Interest rate is compounded 6 monthly. So therefore, T0 equals to 2500. Now, R is therefore 1 plus 0.08 divided by 2. Alright? Now, what I want to ask you to do is in the exam, sometimes you don't get a nice number like this. It could be 1 plus 0.0756 divided by 2. Alright? When you input in the, yep.
Sorry, when you're using R there, are you referring to the common ratio or the rate of interest?
You need, okay, this is a general rule. General rule, you know, is 1 plus R to the power of n.
Okay.
The ratio, correct?
Yes.
Because, yeah?
Yeah.
So, therefore, what I'm going to do is, I'm going to write this down as, whatever you call it, my sequence. The sequence will then be, R will then be equal to 1.04. Alright, think about what I said. This looks familiar, doesn't it? This is the general rule.
Yeah, I was just...
Yeah, yeah. So that would be the common ratio.
I was just, because there's two log XRs.
Oh,
ratio
okay.
and-
It really doesn't matter.
Yeah.
Yeah, I interchange between the capital R and yeah. Okay, this will be the R will be the common ratio, not the
Okay.
not the big R, which is the interest rate. All right. My fault. So you need to think about if it is something like 1 plus 0.576 divided by 2, or 577. All right. Divided by 2. What you need to do is input that as your common ratio. All right. I'll talk a bit more about that in a few in other examples. However, this time I'm giving you something which is slightly more straightforward, 1.04. So therefore, you know Tn plus 1 equals to 1.04, Tn and T0 equals to 2500. Use your class pad, please. You can use your class pad to see how many years. That's better. Now you've got to be very careful. You've got to look at T10 rather than T5 because it's after each period is 6 months. Alright? So be very careful. You cannot look at 5. That is not 5 years. That is 2.5 years. Because we're talking about compounding every 6 months. Alright? So you need to think about T10. So T10 is 3700.6. T10 equals to 3700.6 Therefore, is after 5 years. Alright, think about it. You cannot use T10 is not every year. T10 this time is the end of a 6-monthly period. Just recall that. Alright, what I'm going to do is to get you to start doing some exercise 2A to get used to the simple interest. If you think that 2A is too easy, just pick a couple and then go on to 2B. Alright, I'm going to stop here.